Working, yeah? Cool. Hope you enjoyed some nice pizza. There's some left if you want to take some home later. I'm just going to take 10 more minutes to talk a little bit about the things that are coming up. There's something really interesting about this next topic, which is all about security. Again, sounds like an easy thing to talk about, but if you have a connected data structure, security on parts of the graph, who can see what part of the graph, is really complicated, right? Because it's a connected structure, right? So, okay, I cannot see parts, I cannot see individual elements, but can I still see the traversal? Can I still see the path without seeing the detail of some of the individual nodes? That's basically the question that we're trying to address with Neo4j 4.0. So for example, this is an example of a privacy call center, of a medical call center, right? Where you want to have, there's a path across the across a network, right? But different audiences need to see different levels of detail depending on their authorizations, right? So that basically means that some of the nodes on those paths need to be grayed out, right? So you still need to be able to see the path, but you need to be able to gray out components of the path in real time as you query it, right? And that's going to be something that we are going to be able to specify with roles and specific authorizations on patterns, right? So on specific patterns, you will be able to see, say that a particular role can do this with a pattern, a particular other role can do something else with a particular pattern, which makes it very granular and very specific to the security requirements that you have in that specific case, right? So, like I say, this is an example, right, where you can gray out certain parts of the graphs depending on the authorizations of a particular role, right? And that's a feature of the 4.0 system as well. There's already a pre-release available if you're interested, and it's going to be released in about a month from today. The release candidate was out there, I think, 2 weeks ago. So you can already take a look at it. One more thing, this is Neo4j Aura. I think this is particularly relevant for community members. I don't know if you are one of those people as well, but we have started our journey to become a cloud services company, right? So that means that today, if you have most people that have Neo4j, they either use the community edition and they deploy it on their own servers or in the cloud server, or they buy an enterprise edition from us and they do the same, right? They run it on their own servers, or they run it on their cloud infrastructure, on their virtual private cloud. Neo4j Aura is Neo4j Aura is what we provide as a database as a service, right? So you just register for Neo4j Aura, and depending on your requirements, you basically set the size of the instance that you want, right? Then you say, okay, I'm going to register my credit card, and I'm going to be billed only for the use that I have of the database. Right, so if I want to if I want to use it for a day, I'm going to get a small invoice. If I want to use it for a year, I'm going to get a bigger invoice, depending on usage. And you can tune it up, tune it down as you want. You can say, okay, I want to have a smaller instance now. Tomorrow I have a lot of people coming in. I want a bigger instance, those types of things. You can tune really easily. So that was launched in November, and we've had a great uptake. It's been really good, and it's something that you can check out quite easily. Neo4j Bloom is another short topic that I'd like to mention. What I showed you earlier was the Neo4j browser, right, which is kind of a technical environment to interact with Neo4j. You have to be able to write queries usually, right? You have to be able to write cipher queries. Many people don't want to go near that, and they just want to be able to click around and see and take a look at the structure and take a look at the graph. And we've created a non-technical tool for that, which is called Neo4j Bloom, right? It's basically a visualization tool, right, where all you need to do is you choose some colors, you choose some icons, you choose some data that you want to see, and then you can interact with it just by typing natural language questions, right? You don't have to specify anymore if a particular node is of a particular label or something like that. You don't have to do that anymore. It will, you can still do it, but it will actually help you do that, and then you can interact with the graph without having to write any kind of queries. This is kind of like a generic, generic purpose exploration tool, visualization tool, which is great for people that are, in the early stages of their projects. But usually we find that as people grow their projects, they end up creating like a custom visualization for their application, right? So that's very normal as well. But Bloom is a great starting point as well. It's great. It's very easy to use. I can give you a demo later if you wanted to. And there's a new release coming up. Yeah, that's not accurate anymore. It's next month. And Bloom is available within the desktop or on the server for people to play around with. Right. So it's also, we have a starter program for people that are below a certain threshold can get Neo4j Enterprise for free. They can also get Bloom for free, and that's basically it. 1 more minute or 2 more minutes about Neo4j Labs. We always, that's the great thing of having a community. It's where we experiment. It's where we try things out. It's where we try to find new ideas for future capabilities. There's a couple of them that you can see over here, like for example the Graph Algorithms library, or the APOC library, or an ETL tool, or the monitoring app. Those are all tools that we create in the open source community with the open source community, and that can people can then gradually develop in the open source community, or we can actually help them commercialize it and make it part of a bigger offering. I showed you this yesterday, I think, right? This is called Neuler. It's the Graph Algorithms Playground. This is actually a very easy to use tool to get familiar with graph algorithms, right? So PageRank, Louvain, betweenness, centrality, all of those things that you used to need a PhD for. Now they're just available to everyone, and you can just click around and say, okay, I want to run Louvain. Louvain is a community detection algorithm, right? So it allows you to identify clusters of things or people or whatever in your network structure, right? So things that belong together, right? And they belong together because of some similarity, right? Some kind of similarity. And Louvain is actually, it's a Belgian algorithm. It was developed here in at University of Louvain. I think it's UCL that it was developed. I think, yep. And it's implemented in Neuler. All you need to do is specify, okay, I want to look at a certain. Can you see this? There's a label there, right? I can see which relationship type I want to follow, in which direction, how many times I want to follow it, and then you say, okay, these are the parameters that I'm going to give to the algorithm. It runs over your data set and it visualizes, the things that belong together according to the algorithm, right? And usually you have to tweak that a little bit and iterate over it and try it again a couple of times before you really get some meaningful data. But this is one of those projects that we have in the Neo4j Labs that are already, proving to be really, really useful. To give you an example, we have the VDAB here in Flanders and in Brussels that is using actually Jacquard similarities with Louvain community detection to group together competencies and job paths, as they call it, right? How you can go from one job to another job by mapping out the competencies that belong together, right? And so you can create these domains. You can go to a job seeker and say, hey, you've got 8 out of the 10 competencies to have this job, right? Why don't you take a class and you might actually get that job? And you can go to the employer and say, hey, I've got this candidate over there that already has 8 out of the 10 competencies. Why don't you invest a little bit into him or her, and you might get a great candidate, right? So that's a great application, and it all follows from the analysis of their CVs and job publications with these algorithms, right? So it's super interesting. So I do still have a little bit of a competition later on, right? So when Manu gives his talk, I have 2 more books to give away. We're not a lot of people, so and the books are going to go to the best questions, right? So we'll talk about that later. That's it for me. I hope this was a useful little update, and I'm happily going to pass the baton to Anthony and Manu for their talk about the Sportpaleis case. Is that okay? Fantastic. You have a HDMI? Alsjeblieft. Ah ja, ik ga dat van mij ook afgeven.
on. Is it working?
For me as well. Yeah.
Okay, great. It's the first time I use this, so let's see how it goes. Okay, so the Sportpaleis use case, we did together at in the beginning of 2019, I think in April, somewhere there. We had this project, this opportunity. But let's first start with a short introduction. My name is Anthony. I work at Python Predictions for about 2.5 years. And the topics I've been working on mainly are predictive modeling, segmentations, but also process mining and forecasting. My first experience with graph databases was actually right here at Digitizer as well in 2017. I followed a one-day bootcamp here in this Digitizer place as a first introduction to graph databases. So it's nice to come back to here.
I'm Emmanuel from the Sportpaleis group. I came into contact with graph databases from the financial sector. I saw it there, how they use it to create a shopper's DNA, that's what they call it. Basically, to estimate if a transaction was legit or not, basically. We had some issues with fraud in the past, and this is one of the most recent ones. I think most people have seen this. It was in the news rather because we needed to make a statement. We couldn't allow people not knowing where to get their tickets because they were paying way too much. Prices are doubled or tenfolded sometimes. So the problem is that people come to to concerts. They want to have a great time, and they don't realize that sometimes they bought it on the wrong site because they Googled it. They find it really fast. So
That's so it came into the news, and it was also that period, I think, that one of
after that,
that's one of your colleagues contacted us
mm-hmm.
to have a closer look at your case. But
so yeah, basically there's the law in Belgium. The law in Belgium says that you are allowed to resell tickets at face value, the price that is written on that ticket. You can't sell it for more. You can't have a website that is facilitating selling of tickets, and basically they're trying to protect those customers. It started mainly from football tickets and sports tickets, but it was just as important for concerts and us. We have had the previous detection we had was with Dutch cards. So we had many transactions from Holland that were buying children's shows, cheap tickets. It's 15, 20 bucks to buy a ticket, and they were reselling it for double. It's still cheap. It's too expensive, but we detected with people buying tickets there, and based on their cards, it was very peculiar that we were selling so many tickets to Holland for many shows. They were creating a high demand, so the organizer, in this case Studio 100, went like, oh, if it's so popular, let's add some more shows, and let's add some more shows, and let's add some more shows. And then at one moment, you could buy those tickets on the reseller sites for a cheaper price because they couldn't get rid of it anymore. So at that moment, we were really getting antsy because they were killing our market then. And what we wanted to protect, well, that's the next phase. This is one of this case. Lately, we did we discovered using some new marketing tools, basically fingerprinting of web behavior, also from their payment transactions, that many users were linked to a same session. That's not normal. It's possible that you have in the same household, for instance, using the same computer and the same browser, having 2, 3, 4, maybe 5 different accounts. But if it goes over that, it gets very strange. And number one is a case of our best customer, basically. He bought many tickets, had many reservations, had a huge markup on that amount. So that's what he bought from us. But his markup must have been huge based on this. And the identities is what was really weird. 192 identities on the same browsing sessions. So we started researching, and at that moment we realized that we had something and we had to research it. And I think that's the moment when we contacted you guys.
Yes.
To have some more knowledge and insight on that abuse.
Yes, indeed. So that's a bit the period that Sportpaleis contacted us at Python Predictions to have a closer look at their data. And let's say that the project had 3 main goals. The first was to get a more structured way to detect possible fraudulent customers, because now it was a lot of manual checking, and they were looking for a more structured way to identify the fraud. The 2 was also very, very important, was to visualize possible fraudulent customers. When you have a table, it's nice to have a record with the customer number, but an image like a graph with all its connections tells a lot more than a simple table. So that was the second goal. And 3 was also to get a bit of a touch of who those customers were that bought that many tickets, to understand the profile of those customers. And maybe a 4th goal, but it's not really on the slide, was that it was for us at Python Predictions a nice opportunity to also learn about Neo4j and to develop some more skills in graph databases using a real data set actually at Sportpaleis. So Manu delivered a nice data dump with a lot of details. And let's say we have 4 categories of data that were used within this use case. The first was all about the reservations. So when did someone make reservation, how many tickets, and so on. 2 was more about the payments, how did the payment go. And 3 is more the demographics, the customer info. How long has a customer been a customer at Sportpaleis Group? What is his age, from which country, and so on. And 4 is a very important one. It's, let's say, the initial fraud list. It's a list that Sportpaleis had based on the manual work they have done to already select a set of customers that were manually detected as fraudulent customers. So it's an important source that will be come back in the next slides. So we had this data dump, and the first thing we did was actually to pre-process it in R to already get a little bit of the right structure, because R is something I was more familiar with compared to Neo4j. And I also learned from, I think, the bootcamp that it's always good to do the pre-processing before you implement something in Neo4j. So that's why it was done in R to pre-process this, but then once it was done, we put everything in Neo4j for the fun part to identify the possible fraudulent cases. So this is a bit the same information, but it's more already from the graph structure point of view. It's a bit the graph model, maybe, let's say, the type of info that is used. So on the left, we have the customer info. We have quite some customers, but of course, we have a lot more payment info and a lot more reservation info. We also have an extra source, the online source, which already Manu mentioned a little bit. It's a way of fingerprinting a customer, and so that we were able to link different customers to the same identity. So it's an extra source. So these are actually the nodes that we will implement in the graph, And we also have, of course, relationships that are needed in a graph model. And let's say we implemented two main relationships. One is from the customer to the reservation, and then you have the reservation to the payment. And actually, those two relationships are already a nice way of detecting extra potential fraud cases. We also have a lot of properties that can be added to the nodes, like age, like the lifetime, the country. These are also added as a property of the node, for example, for a customer, as a property to the node. But you can also add the number of tickets to the reservation node as property, and so on and so on. Clear how it's been built? Yes. You cannot win the book, eh? Mm-hmm. Mm-hmm. We thought more about it, I think, in the profiling of the fraudulent cases to see if, for example, if more popular concerts are more a target of fraudulent. Mm-hmm. Yes. It was more from profiling point of view that we thought about it, but not from the graph model.
It could have been an interesting case, though.
Yeah.
Afterwards, because we built it all, and afterwards I played with it, so I noticed patterns. For instance, it was very strange to see non-Dutch speaking profiles buying a lot of Dutch speaking comedy artists, for instance.
That seems very odd.
And combinations like that. But back then we were keeping it simple.
Okay, and how can we detect possible frauds? What I also learned from the day here at Digitizer at the bootcamp was that you have the wild card at Neo4j. We have our first list, the initial fraud list, and the wild card is, let's say, find me any path between one customer and another customer. So we thought, okay, let's start from the customers on the initial fraud list that were detected in a manual way, and let's see which links exist to customers that are not yet on the fraud list. See if there are any connections to see if we can make this first list bigger. That was the main idea that triggered our results. So let's maybe dive in some results. We added some visualizations to show you what we detected and what was nice to see, and also to show to other people at Sportpaleis to really show the link of fraudulent customers with other fraudulent customers, with non-fraudulent customers. So what is on this picture? So you have the pink dots. These are actually the customers, and okay, it's not readable, but it's not so important. But they also have a label inside. One is that were already on the fraud list, and a 0 is that they are not yet on the fraud list. But we have a customer, and in orange we have the reservations, and in red are more the payments info. And what we were looking for is actually, okay, we have a name that we can find, that we see, that is on the initial fraud list, and show me any other path of length 1 to 5. It's since the cipher code is added on the right. Show me any other path that shows a link between a fraudulent customer and a non-fraudulent customer. And then you see, okay, you see here in the center, of course, have all those different customers, but they are all fingerprinted with the blue thing to actually the same person. So that's already first thing to notice.
That's basically how we detected it first.
Yeah.
So the marketing tool offered us that little blue dot, which was the session, and just by manual analysis, we detected many of the pink ones. Not all of them, just many.
Yes.
Too many to be normal.
Yes.
So those are marked 1. We knew there was something off with it. So it's query does a lot more than showing only those.
Yeah, indeed. You see, you can maybe not see it, but there are a lot of ones indeed already noticed on the fraud list. But there are certainly also zeros on the right as well that were not detected yet. And then you can also see, for example, that we have the online identifier, the 2 blue dots, and you would think from the data point of view that they are not the same person or not the same entity. But you can see with this graph visualization that they are connected through the reservation to the same payment info to the same customer. So actually they are all connected in some way. So in that way we could make our potential fraudulent list bigger, and actually then we can also reiterate. We have new customers added, and then we can reiterate and look again for other customers and so on. Yeah, it's the same payment info that can be linked. Yeah. No. Yeah, it's a payment method. Yeah. 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 Yeah, indeed. It's not that one particular. No, it's in general. Yeah. Yes. So this is actually the same query, but just another example that you can see that that's also different payment methods are used by the same customer, and for example, this customer, I'm standing in the way, but this customer has 2 payment methods, but they link through that online identifier again. So you have multiple ways that you can confirm that these are actually the same identity.
Yeah.
Yes. Mm-hmm.
Mm-hmm.
Mm-hmm. Yeah, it's mm-hmm. Yeah.
I made some queries basically that started from all the cards, for instance. Well, I can maybe explain from a customer point of view because that's maybe easier. Start with all the customer nodes and count every relationship with a reservation. Store that in that customer, and then sort the customers from the most relationships with a reservation to less, and then take the first 100 or 300. These graphs would show there as well, of course. So exactly.
No. So this is indeed this is another example with 2 names in the cipher query that were so 2 different names, but you can see that they are also linked to the same flow. So actually with the limited graph model, a few type of nodes and 2 relationships, you can also already detect a lot of interesting possible cases. And actually what I said in the beginning was, okay, the table was the first output that we delivered. It's nice, it's an Excel file. You can just send it and you have a list of your possible fraudulent customers. But it's so an image like this tells a lot more, also to more senior managers.
Yeah, absolutely.
The impact to show a network of customers.
And your first assignment was basically to link a fraudulent customer with maybe an unknown other non-fraudulent customer, because that would be by definition linked and be a fraudulent as well. But while he was doing that, I kept thinking like, okay, we have a graph now, so it's a lot easier to turn it upside down. One card linked to another card, or one browsing session linked to another browsing session, and then expand every single time. And that was mind-blowing because it was fast, it was easy. Yeah.
I think maybe this is the last example we added, but this is more like the more isolated part that you look at from customer to customer side. And I also come back to it, but you see that the path length is limited to 5, because we asked to return the whole data set to show all examples. It was not easy to extend this path to 20, for example, because we were a bit too demanding, I think, to search the whole graph for every possible result. But here you see more the links from customer to customer, with short paths that are one thing on the fraudulent list, the ones, and are not on the fraudulent list with the zeros. So voila, these are some results. Like I said, the fourth goal was to also learn, to enhance my Neo4j skills. So I added some learnings or challenges along the way. Maybe they're not the most mind-blowing things, but there are things that I was stuck upon. The first thing, actually, Neo4j has some, and maybe Rick can elaborate on some points, but the first thing was that we have the default memory settings in the config file of Neo4j. And okay, at the first start, you didn't really think you really didn't think about it, and you just start testing in Cypher on your dataset, but then you notice that you run on memory issues. And then the first thing we did was actually increase the memory settings of Neo4j. They're a bit hidden, I must say. You have to find the config file. Yes. That's the main conclusion from this slide. But once you adjusted the increased memory size, all the problems were solved on the memory part of view. The second point is maybe bits related to my experience of mainly working with relational databases. I was used to just merge every key you have and just add it into the resulting table. But some keys were, or some joins were redundant, let's say. They have a one-to-one connection. And we added this in the first version of the graph into the graph database, but it was just making the graph bigger for no reason. So we then adjusted the data prep and excluded those redundant links, of course. 3 was that you need to import the nodes, like I showed on the one graph with the customers, the reservations. So in the data prep, I started with making unique lists of all the customers. So it's my customer population and my reservation population and so on, and then import those as a separate population, as a separate node population. But Rick already told me yesterday that there are more clever ways to deal with this, more advanced ways. So I try to edit. We have unique constraints, for example, and the merge in Cypher that can deal with it immediately and look for unique combinations and makes the population by itself, right? Mm-hmm. No. Mm-hmm. Mm-hmm. Yes, indeed. Yeah. Problem solved. Voilà. I should have added to the bottom of the slide. Maybe some more challenges. Also sound a bit stupid maybe, but the first one is save your Cypher code in a convenient way. I'm used to just save as, to click it as save as and store it as a separate file, and I found a bit of a struggle to find it the equivalent in Neo4j. So that's one challenge. B was with the wildcard. When I was here, I was really triggered by the wildcard concept of Neo4j. So maybe it was too ambitious, but I started with, okay, let's just try everything, just a wildcard, and poof, see what will result. But if you don't limit the output to the first 10 records or the first 20 solutions, then I understood that it looks for the complete graph for all the possible solutions, and two, we also wanted to have it in a visualization immediately in Neo4j desktop, so it exploded quite fast. So let's say we were able to play around with it. It was very nice, but due to our by imposing too little constraints, maybe it exploded a bit too fast along the way. Yes. We learned it the hard way. Yes, it could go on loop. And three, it's also something that Rick already mentioned, is Neo4j Bloom. Neo4j Desktop allows to make some visualizations, but when you really want to play around with it and visualize tons of nodes of customers, then it also has its limitations. So maybe something like Neo4j Bloom would be more suited for make the complex visualizations. Yeah, a lot more powerful. Yeah. The last part of the project, let's say, was to have a closer look at the profile of the customers. We had some info on the age, for example, on the email, and there we also noticed some interesting things. The first thing that we had was gender, and okay, we see that we have in gray all the customers that are not on the initial fraud list, and in orange the ones that are listed on the initial fraud list. Not on the initial one, but on the general fraud list. And then we noticed that male gender is overrepresented compared to the overall population. But it can be, maybe it's related to the first option that you can, the default option, that they don't think about selecting the right gender. I don't know. Yeah, maybe not. I don't know. Maybe it's not a pledge.
No, I don't think so.
No, doesn't follow. Two was the lifetime, which is think very intuitive as well. That's fraudulent customers are more recent customers. They just create an account and buy the tickets, while the more loyal customers probably are less likely to fraud. Also a bit related to maybe the gender was the mobile. They don't often fill in a mobile number, but still 20% gives in maybe not a correct mobile number, but fills in the mobile number. And maybe the last one is the name in the email. So when you have your name, your first name and last name in your email, maybe it's a sign that you're more trustful, let's say, that you're really using it for the right manners, that you're not trying to fraud. So also in the indication that could be interesting for understanding. Also when you check manually, on possible drivers for fraudulent customers. To wrap up, we have the next steps. Yeah.
Yeah, basically, once we had all those fraudulent users with tickets that they bought, we blocked access to the concerts. When they arrived at the concert hall, they were not allowed to get in the concert immediately. They were sent to a booth where they would get explanation of what happened, and after giving up their ticket and buy a new one, and with a possibility to regain their money from their previous transactions, they could enter again. However, that was extremely labor intensive. We can't pay that amount of money to work every single time for every event that we are hosting, so we needed another solution. One of it was basically to hold back tickets, basically, and just tell them, okay, we know we expect that you were buying this ticket for a fraudulent case. You'll only get those tickets by go pick them up manually with your ID at that booth, and this way you don't annoy customers. They won't be able to be resold those tickets. So that's one of the ways, but they always find ways to circumvent that. It's a rat race, I suppose.
Yeah, but I think the ones there are really customers, are they blocked, let's say?
Yes.
And it was really effective in the way that the ones that were flagged, I think, you don't have a lot of false positives, let's say.
Exactly.
Yeah.
We hit a lot, not all of them. We knew that there were still people getting in, but yeah, it was basically about making a statement, having a system to detect them. We were not sure how we would work with it long term. We have a better idea now. And that's part of the next steps, basically, because in order to hold the tickets back, I should be able to detect a fraudulent case on reservation. I don't have to process after. So right when he's going to get his when he makes his purchase, I should be able to hold back tickets. And like, I'm sorry, I don't trust you. I will hold tickets back. You will have to pick them up at the booth. So that's why we've been looking into a predictive model, basically to detect real time if the transaction is not trustworthy.
Yeah.
Along with that comes your graph database that has to be populated permanently and real time, which is.
How did you make it real time? Because I can see the challenge in a sense.
Mm-hmm.
Did you, because the guy is doing a transaction, you only have the past data available? Or
Exactly. Luckily, the sales are months before the concert, so we have time to process.
Because if you then already know that this customer you could also disable his user account, or disable, block the session.
The faster the user knows that he's been blocked, he's going to just start a new account and start again. So you have to keep it under the radar.
So you let him like go through the whole process and then pick up it at the booth.
Yeah, basically. Mm-hmm. No, we do. All the ones that we detected, we've blocked. All of them. So all those people all have reservations. All the reservations were blacklisted. There were some false positives, but really not many.
But I think it were really the obvious cases as well.
Yeah, yeah, obviously. So we didn't. The moment it went a bit grayish area, we went like, fine, they can pass through. It's about that statement, basically. We want people to understand that they have to buy tickets through the venue website and then to the right ticketing party, and not just Google it and then end up at a reseller. Well, the main victim here is the reseller, because the customer that bought the ticket, he's not going to get in. He's going to. Most of those reseller websites allow to how do you say this? To warn that they were not able to enter the venue, because obviously there's been other fraud cases where they just copy a ticket and they try to sell it twice. So what do you do with a customer that got a copied ticket? So they protect their website and their users, and they have a refund policy. That Dutch man, so the number one fraudulent, the big graphs that you saw, he had to pay huge fees because all those customers have complained. They got their money back, so they paid their tickets once at a real price, at a face price, and the fraudulent ticket was sent back to the reseller, and they have a fee for if you can't get in, you lose 15% or something like that. So he had to pay a big amount of that initial price that he paid.
And it's your best customer.
It's our best customer. We had a personal contact with him as well, because he noticed stuff was changing.
Yeah.
Yeah.
Voilà.
Well, we had a lot of meetings deciding how are we going to tackle this, because it just can't go on, because they have big budgets. You saw those prices. They sell those tickets at twice the price, thrice, 10 times the price. I've seen Adele tickets for $4,000. They have big budgets to pay Google AdWords, stuff like that. We can't fight that. They have a lot of more capital to just invest in exposure, advertisements, and cannot fight that. We have to live from the little margins that we get from a ticket. Yeah, if they sell one ticket, they're okay with buying 10 more.
Because the thing is, you can only detect it if they're somehow connected,
Yeah.
detects all the connections. Because if they don't use the same product, if they don't use if they don't use the same user account, they don't use the same computer.
You would assume that they're very smart and they clean their paths every single time, but obviously they don't.
Not yet, maybe.
Well, some do. We know about some that we went like, oh, okay, they're getting smarter, but not on every aspect. These are 4 nodes. We have more nodes now. I'm not just going to show everything. So
Maybe.
exactly, we don't do this because this is not for money. This is those reseller websites are killing many of our business, so we had to tackle that, and they've been hit a little bit for them because basically their margin is still going to be huge, but we couldn't just let it slide like this. It's a statement you have to make, and there is a law in Belgium that allows it. So if you would not defend that law would be pointless. We didn't earn anything. This cost us money, but it's somehow about image, somehow about we want the experience of that customer to be better than realizing I'm sitting next to a person that paid $30 and I paid $300. We don't.
Basically, another company seizing a lot of your potential profits, and actually, if your buyer buys a very expensive ticket, maybe they won't go to 2 concerts.
Yes, but for instance, I can give an example of Adele. For example, her organization went like, how is it possible that we can get tickets for her concert still now, since you told it's all allowed, for $3,000, for $200? What's in it for me? He's very American, so it's like, how come I don't earn on those margins? We had to explain them that, because in other countries it's allowed. They have platforms where they can resell tickets at margins, and then a fraction of that goes back to the artist. In this case, it doesn't. And in case of Adele, she was very strong about she wants her fans to pay a decent price, not having to pay huge amounts. Because basically the demand for tickets is always greater than the offer. Always. So we could raise prices, but that's not the point. It's not. You wouldn't get the fans in the hall anymore, and that's not a fun experience, I think. Not for the artists, not for the visitors. Well, there's a margin on the tickets, of course. There's a margin on the tickets, of course. And then, obviously, we're a Sportpaleis group. If our venues are full, we'll earn more. If our customers are happy and they like the experience that they had when coming in, and the whole inspiration to consumption should be a fun experience, or because it's a fun business. We're not selling insurance. We're selling a good experience. You're allowed to go. Well, that's what it is, right?
Yeah.
So it's basically our responsibility to keep it fun. The buying tickets for your artist that you really like is extremely stressful, but there's no choice. Everyone wants them, and there's going to be more people unhappy about it than happy.
Yes. Any more questions? I just added those two last bullet points as well, because we only scratched the surface a little bit by playing around with Cypher, but you also have the playground plugin that's Rick already mentioned, to do some more community detection or the betweenness, the page rank. We can also.
We didn't know about that.
We had to call you, Rick, but. Right.
Mm-hmm.
Mm-hmm.
Exactly. And we were looking for networks, relationships. So in my mind, it was, yeah.
Yeah, it was made for it.
Yeah.
All right. Thank you. Well, this was it. So. Some drinks.